Right. Anything that's slower, or low power, would be okay. External hard drives, they consume more power, so a longer cable is always not a good idea.
What do you think of the hilarity of the fact that like the USB 3.0 and stuff, it doesn't have high enough read-write speeds for the new drives that are coming out?
It's putting big fat tires on a wimpy car, so it looks faster. Look at my 19-inch wheel on the Corolla, right? That's basically what it is.
It was just cracking me up. Like I was reading this whole thing on I think it was PC where they were talking about they didn't expect it. So now everyone's like trying to look at like the way that laptops interact with their solid states and stuff like that to squeeze out higher transfer rates.
It will only do it for certain types of jobs. If you have a I/O intensive, type of thing, yes, that will help. But it all depends on where your bottleneck is.
Did you see that quad channel memory review that they had? They did a study of like using I forget the processors they were using, but they were looking at using quad channel RAM with a smaller processor with a smaller cache versus so
okay.
They were talking about if you're building a smaller sized rig, if you should give up quad channel memory for dual channel memory in order to have a larger processor for your motherboard, or if you should go with the quad channel memory to have a smaller processor. And they were doing some interesting comparisons, and they're actually finding that a lot of the performance stuff that you would expect quad channel memory to help perform the dual channel on was actually the dual channel was holding about even because of the larger cache potentially. They didn't really go into why, but just from the benchmarking, they were finding that it actually held about even.
It also depends on what kind of program you're running.
Yeah, well, they ran a whole bunch of benchmarks on the software.
Yeah, because if whatever is running has locality, which means you're executing around the same area, cache is going to be the king. On the other hand, if you're randomly accessing stuff all over the place, then quad channel can be helpful. So kind of there's a break-even point.
They did a lot of compression stuff in video encoding.
That's sequential. That's all sequential, and it's all bandwidth based. It's basically limited by how much information you push into it. So in that case, let me guess, more cache helps.
Yes. Well, it held even with the quad channel. The quad channel held. There's I think it was like 4. I'm forgetting all my numbers. 4 megabytes cache versus 8 megabytes cache. And then it was dual channel. I can't remember if it was the same amount of memory. It was just dual channel versus quad channel. Yeah, I think it was. But
it also depends on how the cache is organized too, because with Intel, I think they have the same pool of cache. Okay. Yeah, they have the same pool of cache, divided into the multiple cores, and then you have the other design. Okay, we have 20 seconds to go. Yes, my watch is synchronized to the atomic clock, so I can tell you exactly what time it is. It's also solar powered. Yep.
The midpoint thing is just paranoid about this 13 things, but the midpoint, you just mean the middle value of the relative 3, or just...
If you sort the 3 values, what is the one in the middle?
Okay.
That's basically the question. All right, it is 1 o'clock. I'm gonna get started. Okay, so we have quite a few things to talk about. The first thing is, do you have any questions about the homework assignment, other than what homework assignment? Because if you have tried to do the homework assignment over the weekend and you have some questions about that, this is a good time to ask. Go ahead.
Are you going to go over it in class or?
Well, I can answer your question in class. I'm not going to go over the assignment in class.
I'll just ask you.
Okay. The only thing I can clarify, based on what people might have in their head, in their mind, is what is the mid value. Okay, that may be the only thing. So I'll give you a few cases, starting with simple cases like 10, 20, and 30. The middle one is clearly 20. Okay. What about 10, 30, and 10? Well, if you sort 10, 30, and 10, you get 10, 10, 30. So the mid value will still be a 10. Is that okay? What about 10, 10, 10? Well, it is already sorted. What is the one in the middle? 10. Okay, so there you go. So in the first case, we have 20 as the mid value. The second case is 10 as a mid value. The last case is 10 as a mid value as well. Do we have any questions about what is considered a mid value of three variables? Sorry? Yep, once you sort it, you pick out the one in the middle. But your algorithm does not have to sort. It just has to figure out what is the mid value of the three. So in some cases, it's easy to figure out. In some other cases, the logic may be a little bit different. So it's up to you guys to decide how you want to format your logic to do it. The restriction is you can only do it with one single expression. That is the restriction. No conditional statements. No multiple expressions, just one single expression to the right-hand side of the assignment statement that is already given to you. So let me just kind of quickly go back to that one because I want to clarify that until I don't want people to misunderstand the question and go like, oh, I thought I could do that. Okay, so this is a file that is already compressed. You just have to download this file and open it up. I don't have that. All right, so let's go ahead and take a look at the source code that is given to you. It's under my downloads folder. It's called findMid. So what it will do when you run the xzv-tar command, it will decompress the file. It will create a folder called findMid. Inside the findMid folder, oops, does not create the find. Oh, I'm already there. Okay, inside the findMid folder, you will find a single file called main.cpp, and your job is to replace this expression here with a single expression. Now, when I say a single expression, it can have any level of operators. Yes?
Are you recording this?
I believe so. So let's check the volume. Yep, I am recording. Okay. So the restriction is you can only use one expression in place of this dummy expression to get a job done. Now, when I said one expression, I didn't say a single operator, okay? So you can choose an expression that can be very difficult, can be very complex, involving 20, 30 operators if you think that is necessary. I'm not saying that you will need 30 operators within the expression. I'm just saying that if it needs 30, go ahead and put 30 in it. Do we have any questions about the restriction of what you can do? What operators are we talking about? Any operator that we have talked about. Yes?
Have to start on the right side of that expression, or can you do like if statements above it?
You cannot have if statements. You can only do a single expression to take the place of what I have highlighted on the projector. Yep.
You don't want it to print out to the screen?
Nope, nothing to print, just change mid. Yep.
I assume we can't have that expression be assigning another variable.
Well, you can. Okay, assignment is an operator and it's an expression, so you can do that if you want to. So let's review what kind of operators we have talked about in this class. Okay, we have talked about the bitwise AND, logical operators. Okay, logical OR, bitwise OR. We talked about you can use comparisons as well. Okay, so that's one big clue. Okay, you can use auto increment, auto decrement. You can use the ternary operator. Okay, you can use assignment operators. Okay, so all of the operators can be used. Are there any questions about what kind of comparison operators are available to you? Okay.
What kind of comparison operators?
Just about everything. Comparison operators consist of the greater than or equal to, less than or equal to, not equal to. So these are the comparison operators. Each one will confirm whether a number is greater than the other number, greater than or equal to, and so on. So these operators you can use as well. Okay, are there any questions about that? Yep.
So just to clarify, only one statement, but not only one operator.
Only one expression, but you can use any number of operators within the expression. Let me give you one single expression that involves a lot of operators. Not that it makes any sense in the case of your homework assignment, but you can do it like that, okay? So you can say, x plus equal to, y question mark, x plus 1 minus y, and then take the whole thing, do a bitwise AND with 0xff, take this entire thing and say minus 1. Yes, that is one single expression. Okay? It illustrates the use of many, many different operators, but it is still one expression. So to the compiler, this is one thing that can go to the right-hand side of a equal symbol. Are we doing okay so far with this? Are there any questions? Are there any questions about what is an expression as opposed to what is an operator? An operator is this one. This is one single operator. This is another operator. This is another operator. But as an expression, this is an expression, but it is serving as a part of a bigger expression. So this is the bigger expression. But that in return serves to a bigger expression, which is this one here, which serves to a bigger expression, which is this one here, which serves as a sub-expression to the overall expression. Question? Yep.
Just to explicitly clarify, you're fine with multiple instances of assignment within that expression.
Say that again?
You're fine with multiple instances of assignment within that expression? Just to
Yes.
explicitly clarify? Okay.
Absolutely. You can use the comma operator, for instance, if you find there's a need to do it. So your expression can be x equals y, y equals z, plus plus y, and then take the entire thing plus 1, and put this whole thing into z, and so on. Now, does this expression make any sense? No, absolutely not. I'm just giving you an example of, yes, you can have multiple assignments within the expression because each assignment operator makes its own expression. Is that okay? All right. How many people actually try to get this done over the weekend? Okay. Are you guys close to it? Okay, all right. Any other questions? You can use extra pairs of parentheses, okay? You might find parentheses to be very useful because this way you don't have to memorize the operator priorities, okay? Which one is applied first, which one is applied second. If you use extra parentheses, that becomes a non-factor. Okay? Any other questions? No other questions? All right. If there are no other questions, I'm just going to leave this one as is, okay? If you can think of any questions during class, just let me know and we can come back and take a look at this. What we are doing today is we are moving forward, okay? I sent an email to the entire class, telling you guys that we are moving forward to control structures. So we are not, focusing on expressions and operators anymore, and now we are focusing on control structures. Which is kind of interesting in a way because in most other classes, they would use control structures to become the solution to the homework assignment that you're doing right now. But because of certain operators being available in C and C++, you can actually get the assignment done without using control structures. Okay? So we'll go ahead and just get started with control structure here. Conditions in C and C++, we have talked about these operators already. So we talked about the comparison operators. The only two comparison operators that are kind of confusing in some ways, but you won't be using those in your homework assignment, is the equal to. See how equal to or comparison for equal to has two equal symbols instead of one. And also the not equal to is an exclamation point and an equal to. It is not a vertical bar and an equal to. It is very common for people who are starting off with C and C++ to make that mistake. Okay, so instead of using two equal symbol, people use one. Syntactically speaking, it is correct. Does it do a comparison? No. Yep.
Does the single equal symbol, would
would that be like an error, or would that, or is that?
I just said it is not an error. It is syntactically correct. It just doesn't do what you think it should be doing. Okay.
So you would use that in another language.
Well, it depends on which other language you're talking about.
Okay.
Okay, so let's go ahead and do a few examples. Okay, so I'll let you guys figure out what it's going to do. Okay, so here's I'll give you a complete program so that I'm leaving nothing to imagination here. Okay, so here's a main program, and we'll get ourselves maybe two variables, int x and y. Okay, so x and y are both integer variables, and then we'll go ahead and say x equals 10, okay, and then we'll say y equals x double equal 10. Now let's make that 15, and then it'll return 0. In other words, this is my entire program. Obviously, it doesn't print anything. It doesn't need to, because we have GDB, so we can actually see the result of the statements using GDB. So the question is, what is the end result by the time we get to the return statement? What is the value of x by the time we get to the return statement? X has a value of 10, because x gets a value of 10 in the first statement. This is comparison, it's not assignment. Okay, 2 equals symbol means I'm comparing. So what about the value of y? No.
10.
Okay, remember when you compare, it will give you either a true or a false. Okay, is it true that x does equal to 10, or is it false that x equals to 10? It's false, and false is represented by which integer value? A single 0, right? So y should end up with a value of 0. Okay? But every time I claim something like this, what do? You double check, you verify it, okay? So this is a very important step in this class, okay? You have got to, make it a habit, okay? Every time you say, okay, that looks kind of tricky, okay? Let's test it, make sure that's the way it works, okay? So let's go ahead and make a program like this. So I'm gonna give you a particular name. We'll call that example 1, okay? Just because this program doesn't do a whole lot more than just that. So after this, I'm gonna mess up this program just a little bit, just by deleting one character, and then we'll see what it does, okay? X equals 10. And by the way, how do we call this equal symbol in this particular expression? What does it do? It's an assignment operator. Very good. Okay, it's not a comparison operator. Y equals 2, x double equal to 10, 15. And in this case, the double equal to is, how do we call this operator? Comparison for equality. Okay, we're comparing to see if the two sides are the same or not. So as a result, this expression, x equal to 15, will either give you a 0 if x is not exactly 15, or it will give you a what value when it is 15. Not necessarily a 1. How do we represent the value of true as an integer in C and C++? Anything other than 0. Okay, so any non-zero value can be in y if x turns out to be exactly 15. Okay? All right. And then we'll have a usual return statement, which is not 100% necessary, but we'll keep it this way. And then we'll go ahead and test this program. Okay, G++-C. This time, I'm not going to turn on warn all, because it will tell me about potential. Well, actually, in this case, I can do the warn all. It's not going to be a problem. When I mess up this program, it's not going to be the case. -O main, and then we'll ex1 is better. ex1.o. That's the linking part of it, and then we'll go ahead and run the program using GDB. This program, it makes no sense to run this program without GDB, because there's nothing that is visible, or nothing that can be GDB. Oh, right, I forgot. You don't have to do this part, I have to, but yeah, go ahead.
Did you go over this kind of stuff in previous lectures? Did you go over what you're doing right here in previous lectures?
I think I did.
Okay.
even this one. I have to do it because your GDB is not installed in my live environment, but it is installed in your virtual machine, so you don't have to do this part. Okay, so now I can use GDB to debug the program. Just do a list. Oh, I forgot one thing. What did I forget? If the compiler or the debugger is telling me no symbol table is loaded, which step had a problem and what was the problem? If the symbol table is not loaded, it means when I compiled the program, I did not specify to include debug information. Okay, so was it the first command that was the problematic one, or was it the second one that was problematic? The first one, because it was with the compiling command. So I have to go back and rerun my compile command to include -G. Okay, -G is for including debug information. And once I recompile, I have to relink because otherwise the executable is not affected. So now I can go back in here, list the program, put a breakpoint on line 5, then just go ahead and run the program. I'm now stopping on line 5. Before I execute line 5, I'm going to check what is the value of x. It turns out to be 0 for the first variable all the time, but that's not reliable. Okay, so don't count on it always being 0. Single step, x should be, I just ran line 5, so x should have a value of what? 10. Okay, very good. So now we can go ahead and single step again. So line 6 is now executed. So we print x, as you guys already said, x should still have a value of 10, and y has a value of 0 because 10 equals to 15 is false, and false is represented by a value of 0 as an integer. So y has a value of 0. Okay, so this is a fairly simple to understand program. Let's take a look at a different one. So what I'll do is I'm going to copy ex1 to ex2. But in ex2, I'm going to mess up a little bit here. Okay, so what I'll do is I'm going to mess it up by taking out the equal symbol. Okay, so now on the current line, let me turn on the line number so we can refer to line numbers. So now on line 6, what does it become? It becomes 2 assignment operation. The first one to change y, and then that assignment operator in return gives us a value of 10, which we use to update y as well. So in this case, by the time we get to the line of the return, x will end up, no, I take it back, 15. Okay, so 15 is going to be in x as well as y. Okay, which is very different from the result of the previous program. Are there any questions, okay, before I switch to the debugger? No questions? Okay. So let's go ahead and compile this program. This time I remember to do a -G. And then we'll link the program and run the debugger. Same thing, put a breakpoint on line 5, run the program. X before line 5 has a value of 0, single step. After line 5, x has a value of 10, just like before. No big deal here. Single step one more time. Print what is in x, it's 15. Print what is in y, it's also 15. Okay, so how much change did I make out of these two programs? Just one character, right? I took out one single equal symbol from the second line, and this is the effect. The outcome of the program is completely different because all I did was to replace a comparison for equal to an assignment operator. Do you think people make the mistake a lot? Yes. Do you think you'll be making this mistake? But it's a very difficult one to catch, okay? Because syntactically it looks okay. The compiler does not complain, okay? The question now is, could the compiler have complained about this one? So let's see, when we compiled, it did not complain about it. And if I turn on something else, let's turn on pedantic. I don't think that's going to do anything to this one. Pedantic. It does not complain about that. If I turn on optimization, I don't think that will do it either. Nope. So the compiler is completely okay with putting your assignment operator inside the right-hand side of another assignment operator. So when you check your code, you have to be checking for something like this because the compiler cannot tell whether you intend to compare or whether you intend to change the variable. Are we doing okay so far? Okay. This is nothing new. I just want to point out, very common mistakes that people make when they write programs in C. Okay, let's make another common mistake here. So I'm going to copy EX1 to EX3, and this time in EX3, I'm going to change this operator to this. From an earlier exposure, okay, just about 10 minutes ago, what did I change it to? What does a single exclamation point mean in C++? It means logical not. Okay? So this means logical not equal to, which is not equal to. In other words, all I'm doing on that line, let me turn on the line numbers again. Okay, so on line 6, okay, the expression in the parentheses is saying, is x different from 15? That's what it's asking. Okay, it's either true, which will give you a non-zero value, or it is false, which will give you a value of 0. In this case, what do you think should be the value of y after line 6? Any number other than 0. Okay, most likely it is 1, but I cannot count on that because it can be 215. Okay, because that's also not 0. Okay, so let's go ahead and run this program just to be sure this is the way it works. Okay, so we'll go ahead and do a g++ -1 all -g -c ex3.cpp g++ -o ex3 ex3.cpp and debug this program. Oh, I forgot the -g somewhere. No, I have to. Oh, the second command I did not use the .o. That's fine. There we go. Put a breakpoint. I'm not even going to put a breakpoint on line 5 or 6 anymore. I'm going to put a breakpoint on line 7. Run the program. I'm just about to execute a return statement. Print x. What should be in x now? X, not y. Which line changed the value of x? Line 5, okay? And it changed the value of x to 10, okay? So x should have a value of 10, which is good. What about the value of y?
Not 0.
Some non-negative value, okay? Very good. A non-negative, non-negative, non-zero, okay? Some value that is not 0. But I have no idea which one, okay? There are 2 to the power of 32 minus 1 values that are non-zeros. And I have no idea which one this compiler decides to use. It turns out to be 1. But there's no guarantee, okay? Remember, there's no guarantee that y has a value of 1 at this point. The only thing you're guaranteed is it is not 0. That's the only thing you're guaranteed. Yep.
Why would you want like a mystery y number? I mean,
mystery y number?
Well, in Python, that would just be true. It's like
because
Boolean.
in C there's no Boolean. There's no Boolean type.
So how do you use y now that it's assigned to some number within a 32y?
If you use y in the context of a Boolean value, it is the same thing as true.
Oh, so it's just stored somewhere.
Any value that is non-zero is true in C and C++.
I'm just wondering now, what would you do with y now that it's been assigned a number other than 0?
You can use it in a conditional statement. You can use it in a ternary operator. There are many places where you can use it on one side or the other of all the logical operators. Logical or, logical and, logical not. Okay? Alright, so now we're going to throw a wrench into this program. EX3 to EX4. Okay, make a copy of that. And this time I'm going to make one change to it that is really hard to spot as well. I'm going to change this character, okay, to this. Do you see how visually it's not easy to pick up? It all depends on the font that you use, okay? If you use particular fonts, maybe the exclamation point will stand out more, but if you use other fonts, maybe the exclamation point and the vertical bar will look almost the same. I have seen fonts that will do something like this. The exclamation point is like a column of dots with a single dot here. Vertical bar is a smaller, a shorter length of solid, pixels, followed by another solid length of pixels. So if you pick a font that looks like this for the exclamation point and looks like this for the vertical bar, and you make a mistake like that, it becomes very hard to see visually. Am I making that point okay? All right? All right. But the question is, isn't the compiler going to complain about this one? Because there's no such thing as a vertical bar equal to 15. How many people read compound assignment operators from the operator? And okay, so what do you think that's going to do? What is it equivalent to? X bar equal to 15. If I expand it out and not to use compound assignment, what is it the same as? That's a way to express it, the same thing. Okay, so I'm going to use comments here. X bar equal to 15 is the same as X equals to X bar 15. That's the whole thing about compound assignment. It's just a shorthand. Okay, you're using the left-hand side of the operator to work on the operation. In this case, it's a bitwise OR. Okay. All right. So I'm just changing the program a little bit here. The focus is this character here. I replaced the exclamation point with a vertical bar, but that would also change the end result completely. Okay. So we'll see how this is going to change the result. Are there any questions before I get out of the editor? Questions? All right. So given enough time, you are supposed to be able to figure these things out because all of the information is already in the slides from the previous chapter, okay, with expressions and with expressions and operators, and also in the current topic. So G++ 1 all -C -G ex4.cpp. All right, so now we can gdb ex4, list the program. I'm just going to put a breakpoint on line 7, run the program. All right, first question, what is in X at this point? How many times was X changed in this program?
Twice.
Twice, very good. Once on line 5, we know about that one. That one is pretty obvious. The second time was on line 6. Okay, so on line 6, we use X bar equal to 15 as a compound assignment operator, which means we first have to compute what is the bitwise OR between 10 and 15, and then that result will now be used to update X. So that's how X is updated twice. So what is 10 bitwise OR 15? How do we do that? Well, find out how these two numbers are represented in binary first, okay? 10 is 100, 1010. This is a bitwise OR. What about 15? That's an easy one. 15 is just 1 less than a power of 2, right? 2 to the power of 4 is 16. So that will make 15 what? 1111, okay? That makes the calculation very easy because anything OR 1 is a 1. So that means the result is 1111, which is in base 10, 15. So that tells me that X is updated to 15 because of this expression. But this expression has two things that it will do. The first one is to change X. But the second row of this expression is it will provide a value as the right-hand side to y equals 2. So what value is it going to provide to y equals 2? 15, exactly. So both x and y will be 15 in this case. So when I say print x, it is 15, print y, it is 15 as well. For those of you who like more of a challenge, change 15 to, I'm just trying to think of a particular value that will make a little bit more sense. Change 15 to, let's see, that one has a 2, no, it doesn't have a 2. Change 15 to a 13, okay? In this case, it'll change the 15 to a 13 and see what it does. I'll leave it up to you guys to work on it, okay? What I'll do is I'm going to change the code here so that we have it, in recording. But I want you guys to work on this, okay, so that you can tell me what will be the value of x and y by the time we get to the return 0 when we're all done with this. It's a test on whether you understand bitwise OR or not. That's basically what I'm testing you. Are there any questions at this point? No questions? This is all good?
This is the homework assignment that we're able to outline.
Oh no. These involve operators that you should understand already based on the previous chapter, based on the previous topic. So I'm using these to basically test, whether to give you guys a self-assessment. Okay, I'm not collecting any work today. So if you cannot answer these questions or don't understand the operators, your overall grade is not impacted. But on the other hand, if you look at these operators and go like, I have no idea what that operator is, or I don't know how to work on those, maybe it's time to review the material, because I promise you these will be in the first exam. Okay, so you have to make sure that you understand all of these things by reviewing the material. But if that is not helping, then come to me so I can help you understand the material. Okay. Question?
Will we have an exercise or homework working in BIM with heavy operator use like this in order to?
We have some exercises like that. Yeah, so we have a little bit of assessment for that, for this sort of thing. Okay. All right. So now we move on to the next topic. We are moving on to control structures. Okay. So what control structure is? Let me just kind of give you the outside view of control structures. So control structures basically consist of, these topics here. The first one is basically just saying what is an expression in C and C++. Well, anything is a condition in C and C++. In your previous class in CISP 300 or 301, you might be told that you can only use a Boolean value as a condition. Something that can either be true or false can be used as a condition. In C and C++, anything can go. Okay, anything that can be 0 or not 0 can be considered a condition. Integers, okay, floating point numbers, and so on. That's what that slide is for. The second one is an expression statement, okay, because when we get to control structure, everything will be organized in units of statements, not in expressions. Okay, so we have to be able to turn what we knew before, which are expressions, into statements. How do we do that? I'm pretty sure some of you have read this slide already, which is a really short one. How do we turn an expression? Give me an expression, and how do you turn that into a statement? Add a semicolon, exactly. Okay, so any expression followed by a semicolon is a statement. Okay, it's called an expression statement, which can be useful, can be useless. Okay, when I click on this slide here, you can see that this here, I'm not sure how many of you can read this quite correctly. X equals to 0, x equals 0 semicolon is it's a useful one. Okay, this is a useful expression statement because it does change the value of x to 0. On the other hand, 6 followed by a semicolon, which is also a statement, is completely useless because, hey, what does it do? Nothing. As a statement, it doesn't do a single thing. But is it syntactically correct? Absolutely. Okay? G++ may give you a warning and say, hey, this statement doesn't do a single thing, but it will compile it. It doesn't complain about this as an error. Okay. All right. So moving on to conditional statements. Okay, so the next one, the next one is called a block compound statement. This is very important. Okay, the slide is very short, but nonetheless, this is a very important concept because what it says is you can use a open curly brace and a closed curly brace to turn any number of statements into a single one. Because logically speaking, a block statement is a statement. But between the open and the closed curly brace, you can have as many statements as you want. In other words, this is kind of like a folder when you think about files. Okay? Can you have a folder with nothing inside? Yes. Okay, when you first create a folder, it has nothing inside. Can you have a folder with a gazillion other folders inside, assuming your hard drive has enough space? Yes. Can you have a folder inside another folder? Yes. Can you have a folder inside a folder inside a folder? Same thing here. Okay, so block statements can nest other statements inside even other block statements. Are there any questions about a block statement? It's just an open curly brace, any number of statements, including 0, and then a closed curly brace, which means open curly brace, closed curly brace by itself is a statement, even though it doesn't do a single thing. Does everybody understand that particular, no pun intended, statement? Not C statement, but just general English statement. Is that okay? All right. Because once we have block statements, then we can have fun with all the other control structures. So the other control structures, we can start with conditional statements. Because you have taken cisp 300 or 301, most people would think, we know what a conditional statement is. And sure enough, you do understand the concept of a conditional statement. The question is, do you understand how to parse a conditional statement like a C compiler or C++ compiler? That is the key concept here. So assuming that you have read most of this stuff on here, I'm just going to skip to this part here. We'll focus on this little construct here, and the meaning of this is not important, okay? What is important is what are the statements, or what are the statements that is affected by the condition x is less than y? Is there one statement or two statements that are affected by the condition x is less than y? One. Only one, exactly. Okay. But the indentation clearly indicates that both statements are inside the conditional statement. That's not how the C compiler sees things. Okay? So I'll explain it once, how the compiler sees things, and then we'll try to do it again with some other examples. Okay, so the compiler is first going to encounter a keyword. Okay, if is called a keyword because you cannot have a variable named if. Okay, this is one of the reserved words. You cannot have a variable named if. So when the compiler encounters the word if, it will suddenly have expectations. Okay, it will say, oh, this is the beginning of a conditional statement. I should be expecting the following. Okay, what do you think you should be expecting? We'll go back a little bit more. Maybe not. Okay, so what the compiler is going to be expecting is open parenthesis, a condition, close parenthesis, and a single statement to execute if the condition is true. Okay? Let me just explain it using I'll use the whiteboard to explain this. So as soon as the compiler sees the word if, okay, it will automatically come up with a set of expectations. A single open parenthesis, it will expect a condition in the form of an expression, a close parenthesis, and it will also expect exactly one single statement. Okay? So just by encountering this word, these expectations are all set up. Are we doing okay so far with that part? what the compiler is expecting right after the word if is encountered. Okay, so in this case, do we meet the expectation of an open parenthesis? Yes, we do. Very good. So the compiler will now say, okay, the expectation of an open parenthesis is met. Then what is the next thing it's going to expect? An expression that will be used as a condition, right? So either it is 0, which means false, or it is non-zero, which means it is true. And do we have that expression here? Yes, x is less than y is an expression. It will give you a value of 0 or non-zero, so it meets that requirement. Okay, good. EXPR as an expression is met. What is next to it? Close parenthesis. So the expectation of a single close parenthesis is also met. Okay, it's all good. That's the easy part. Now the C compiler says, I also want a single statement. One statement. Okay, what is the compiler seeing next? Well, a new line character doesn't mean anything to a C++ compiler, so the first thing it sees is Z. That's the first thing it sees. Okay, so it doesn't really panic, it doesn't freak out. Okay, even though Z is not the beginning of any control structure, it is the beginning of an assignment, an expression statement. Okay, so anything that doesn't fall into special control structures, is an expression statement. Can Z start an expression statement? Yeah, it's okay. So then it will parse this portion here. Z equals Y is an expression. It's an assignment operator. Okay, but overall speaking, it is an expression. Okay, and then we have a semicolon next to it. What does the semicolon do to an expression? It changes it to a statement. So the compiler will now say, this gives me a single expression. Okay? So this expectation of a single statement is also met at this point. And that concludes the entire conditional statement. And then somebody in class is going to say, but wait, what about n equals n plus 1? It's okay by itself as an assignment as a statement, but it's not a part of the conditional statement. It occurs after the conditional statement. Yep.
It's going to be bad form to keep it spaced within the same orientation of the if statement being met.
Yes.
Yes.
Absolutely. Okay? But this happens when people are used to Python programming and they switch to C. Because in Python, you have no open or close parentheses. You use indentation to indicate nesting for everything. Not in C. Not in C++. So you, in particular, will have to observe this type of thing because you're not used to open and close curly braces. Okay. Are there any questions that this n equals n plus 1 has absolutely nothing to do with the conditional statement? How do we fix it? Oh, sorry, there's a question back there.
I was about to say, if you added values to the x and y, could it affect what z equals, and also...
Oh, the relationship between x and y will certainly impact what z has, but it will not impact what n has, because n equals n plus 1 will execute regardless of how x and y relate.
Okay. For example, like let's say you give values like 1 and 2 for x and y.
Okay.
And so 1 is smaller than 2.
Yes, it is true.
So that the parentheses statement would be true.
Yes.
What would z equal after that?
Then z will get whatever y has, but since you said y has a value of 2, then z will also become 2.
Okay.
But that's not the tricky part of this particular construct. The tricky part is, will n be incremented? That's the question. And the answer is n gets incremented regardless of whether x is less than y or not. Because n is n equals n plus 1 is not in the conditional statement. Okay? Do we have any questions about how this line is parsed?
Yeah, how is it marked? Yeah, I don't know.
Well, I just described it. Okay, so
No, you just scroll to the top. I had to go to the bathroom real quick, so I don't.
oh, okay. Well, I can't do that, because, we have already gone past that point. But it's recorded, okay? So the good
Okay,
part is
okay.
it is recorded, so you can replay that portion. Yep.
So the n equals n plus 1 doesn't have to do anything with the conditional statement, right? So
Say that again?
no, the n equals n plus 1 doesn't have to do anything to the conditional statement.
That is correct. In this particular case, n gets n plus 1 is going to happen regardless of whether x is less than y or not.
Is there any way to break out of braces as a compound statement?
What do you mean by breaking out of? Like do a part of it and then skip the rest?
Interrupted from executing this part of the condition.
So you want to skip a certain part of the program to go to another place?
Effectively, yeah, like if it says do the statement, it goes to a compound statement. Is there any way for it to stop in the middle of the compound statement or just break out of that?
Well, but where are you breaking out to? That's the question.
Just outside of the brackets, I guess.
Okay, there are several answers to your question. The first one is yes, there's a G word, which is go to. Do not ever use go to in your program in a C++ or object-oriented programming or data structure class. Okay, the only time you can use go to as a C++ construct is in cisp360, which I teach. And there's a reason, there's a good reason why you have to do it, okay? But in every other class, okay, do not use the G word, okay? It's a taboo. That's why we say it's a G word. We don't say go to. Yeah. Okay, so that's the first answer. The second answer is yes. There's also a statement called break, okay? So break can also break out of a nested control structure, but it is still considered bad programming practice. So the best way to do it, which is the third answer, is you have to structure your if-else correctly, or in the case of a loop, you have to structure your condition of the loop correctly, so you can break out of the conditional statement or the loop without using go to or break. Okay. All right. So I'll give you one exercise. Okay. What about this one here? What is the structure of this code? That's the question. Okay. I'm not asking you what it's going to do. I'm asking what is the structure of the code. Okay. If you are going to draw a picture to represent this code, what is it going to look like? Well, the first question is, how will a compiler see this code? This is 100% legitimate, assuming x, y, and z, and w are all integer variables. Okay, this is 100% syntactically correct, which in Python would be a problem. Okay, Python would definitely choke on something like this. But C doesn't really care about end-of-line characters. End-of-line characters are the same thing as a single space. Okay, so you can use new line characters, but you cannot use new line characters. It's the same. All right, so what we'll do is we'll take a look at this code, and then this time I'm going to use Notepad to help document how a compiler will see this code. I was just talking about this with my colleague with the Raj subsidiary, which many of you will probably take a class from prior to this class, and I was asking him, do you think I'm confusing people more when I explain to them how a compiler sees things? Well, I think it is necessary, okay? Because you are writing code in C++, okay, to tell a computer how to do things, right? But what are the rules dictating, how the computer is going to understand your code? The syntax of C++, right? And that's exactly how a compiler thinks. So I think it is very important to understand how a compiler sees things. All right, so the first thing the compiler sees is, okay, let me just kind of focus on just one screen so we don't have to flip-flop between screens. So I'm just copying this code onto here for now, so I can just maximize this screen and not look at the browser, at least for the time being. So we are now just focusing on this text editor, on this one single statement here. Well, it's multiple statements, but we want to figure out how it is structured. the first thing the compiler sees is what? If, okay? And automatically it sets up expectations, right? So it sets up the expectation of open paren, some kind of expression, close parenthesis, and a single statement. Okay? Those are the expectations after encountering the first if. Is that okay? So we'll keep track of whether these things are met. Do we see a open parenthesis after if? That's okay. Do we see an expression? So expression is okay. So x is less than y is the expression. Do we see a close parenthesis? Yep. Here comes the confusing part. The confusing part is when we expect a single statement, what do we see, or what does the compiler see at that point?
The keyword.
The keyword if, right? So that means, okay, this I have to use a whiteboard because it is graphical. Okay, so this part, I have to use the whiteboard. You might want to write it down on a piece of paper, okay? This is why, even though I do screen record everything, it is still helpful to have a piece of paper and a pencil so they can, still jot down notes, because some of this, is hard to explain. Okay, so we have if, okay? So instead of seeing if in a linear fashion, what we'll do now is to see it as what we call a tree. In other words, we look at if, a conditional statement, and then we ask what kind of components are we expecting, okay? So we can kind of say we expect an open parenthesis, fine. We expect a closed parenthesis, we expect a single statement here, and then we also expect a single, we expect an expression here and a statement over there. Is that okay? So what I'm doing here is, instead of linearly expressing what a conditional statement looks like, I'm using a kind of more hierarchical way to look at it. Is that okay so far? Nothing more, it's kind of like a folder inside a folder, okay? Expression is a folder inside a folder, statement is a folder inside a folder. Question? Yes?
So those lines represent the parentheses, and that one line that's in between is like the text embedded inside?
Correct. Yep, exactly, because the parentheses are enclosing an expression, okay? So this is the overall structure of a simple if statement, okay? So in this case, when we are parsing, what do we see? We see if, okay, and that automatically set up these particular slots, okay? The open paren is not a problem. The expression, what goes into here? If you look at the code over there, x is less than y, right? Okay, so x is less than y is an expression that will fit into this particular slot. The big question is, what is going to go into this slot here?
There's going to be another if.
Exactly, we see if. And then what do we say when we see the word if? What kind of expectations are we going to set up?
Close parentheses, expression, close parentheses.
Exactly, the same structure, right? So we're going to use the same thing here, open paren, close paren, an expression here, and a statement here. That's my expectation. Is that okay? Now, what is after the open paren of the second if? X is less than z, okay? Very good. X is less than z is not going to go here, okay? And then we have a single statement after that. What is that?
W equals 1.
W equals 1. Very good. And that's a statement because of the semicolon. But this time we have a else. Okay? Else is optional. So the question now is that else associated with x is less than z, or is it associated with x is less than y? Which conditional statement am I parsing? Or am I still parsing at this point? The first one is kind of in the process, okay? But which one am I focusing at this point? The inner one, x is less than z. So that means, the else is going to fall into the nested, the inner conditional statement. So we have an else here, which is optional, and then we also have one more statement here, which is w equals to 2, semicolon. Yep.
So like saying if and if?
There's no such thing as and if.
Well, I mean, it's saying if x is greater than y, then the process stops. So if x is less than y and if x is less than z, then w equals 1, else whether else x is greater than z, then it would be w equals 2.
The big question is, why is that else associated with x is less than z? That really is the most important part of this discussion.
But did I say it right?
Yeah,
Did
you got it right.
Then that's why I said and, because now just like, well, English language wise, you know, like.
Well, it's more like
If-
then than
if-
and.
Oh, you're right. Yeah.
Because
Yeah,
you
you're
know,
right.
because this if statement here, most people would say, you know, then if blah blah blah, then if da 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 da. Okay, but in C, in C++, we don't use the word then, unlike Visual Basic and some other programming languages. There was a question back there. Go ahead.
I was just about to say, it wouldn't even go to the next if the first one was false, so it has to have the else because it's comparing two expressions.
No, this has to do with how the compiler sees things. Okay, so the compiler, to be more complete, a conditional statement has all of these components. These are mandatory components, but it also has optional components. So the optional components, which I'm going to use a dotted line here, is a word else. Okay, but if you have the word else, you also have to have another statement here. So this part being completely optional means if you have the else, then you must have the statement. And the way we structure that code is there is an else. But we are actively parsing the inner conditional statement, and that's why the else is associated with the inner conditional statement, not with the outer conditional statement. Yep.
So what would stop parsing? Because I was working with assumption that as soon as it can technically return a value, stop. But
Well, let's take a look of how to draw this picture in a different way. Okay, we'll do this as a trail map. Okay, so this is a typical way that I draw a trail map for a conditional statement. Okay, so any conditional statement looks like this. There's a way to split the path, and there's a way to merge the paths. Okay, this is the outer conditional statement. What is the condition of the outer conditional statement?
X is less than y.
X is less than y, very good. So x is less than y is the question that we are asking. If it is true, we go in one side, we go on one side. If it is false, we go on to the other side. Okay? Every conditional statement has two branches. Whether you do something with each branch or not is a different question. Okay? What if x is less than y is true, according to the structure here?
Then you try to figure out if x is less than z.
Yep, exactly. So this is a nested conditional statement. Well, a nested conditional statement is a conditional statement. So it has exactly the same structure as any conditional statement, which means it has a split, it has a merge. Okay. So here we have a split, and we will merge. Yes, that works. Okay. What is the condition of the nested conditional statement?
X is less than z.
X is less than z, very good. And if x is less than z, what do we do?
Then w equals 1.
Okay, very good. So this is the actual thing to do here. What about the false here? Do we have anything to do when x is not less than z? W equals
W equals
2.
2.
Very good. So we have w equals 2 here. All right, the picture is almost done. The next question is, what about x is less than y is false? Do we have anything to do? Does the outer conditional statement have any else branch?
No.
No. If else is not specified, it doesn't mean there's no else branch. It simply means it's just a straight path, shortcut, nothing to do. Yep.
So if you wanted to connect the x is less than y false statement to one of the conditions, like w equals 1 or w equals 2, would you use the or statement, for example?
No, you can use curly braces. Okay, you can use curly braces to close a conditional statement earlier. Okay, for instance, let me give you.
So you basically just make two conditional statements if you want to do that. Is what you're saying?
No, what I'm saying is, what if I want W equals to not to be here but over here? Okay. Well, what you have to do in that case is you have to change the way this is structured. So let me just go ahead and change the statement itself. So this time I'll give you the same thing here, but this time I'm going to use curly braces. Okay. Okay. So if you look at the new version, okay, let me just highlight the new version here. That's going to put W equals to and associate that to the outer conditional statement and not the inner conditional statement. Okay? Is that making any sense? Because the curly braces clearly stops here and say, oh, this is the end of the inner conditional statement. Well, then by the time we get to the else, who can this else be matched up with? The outer conditional statement where the condition is x is less than y. Yep.
Are those squiggly things creating a block of statements?
That's the curly braces are used to form block statements. In other words, to the outer conditional statement where the condition is x is less than y, this is the then statement. This entire thing is considered one statement to the outer conditional statement.
So it's like parentheses for expressions only with
exactly.
words.
Yep, exactly. And it doesn't cost you anything. Okay, if you put in extra open and close curly braces, it does not cost you anything in terms of execution time. It just makes your program look a little bit longer. Okay. Are we thoroughly confused at this point? Yep, go ahead.
If I wanted to put indentations in, I could.
Yeah.
Without getting in trouble.
You can put indentations in if you want, but the compiler does not care.
Right, okay.
Which means if you put in the wrong indentation so it looks one way, it doesn't change the behavior of the code.
And so on Python, because it's indentation and an interpretive language, that's why it can catch it right away if there's
That is
proper
correct.
indenting.
Yep. Well, Perl is interpretive too, but it works differently. All right. So are we getting confused here, or are we at least? Yep. Go ahead.
So I just kind of want to make it clear. Does C++ have the specific OR statement, or do you have to use the curly brackets?
It has OR statements, but not statements. It has the OR operator, right? Logical OR, bar is an operator. So you can express, a logical OR if you want to. But this is eventually you will see nested conditional statements, and this is important because you have to understand, all the problems you can get into without using curly braces. Okay. Okay. Even though many of you will now at least understand how each one statement is interpreted and how the structure is different because of how the way we specify all of these things. Just hold on 1 second. I think everybody in this class would agree this is not easy to deal with. Okay? You can think like a compiler, but people make mistakes. And it's very easy for us to make a mistake and misunderstand the actual structure of the code. Okay? So we will talk about a way to kind of get around this problem. It's easier than you think. Okay? And let me address your question. Go ahead.
That sounds weird. Can you do an if or if?
If or if.
Like if,
what about if something or something?
If something or
You can do that. I mean, anything, you can put anything that is either a zero or non-zero inside here, including a disjunction or state or expression. Okay, so what I'll do instead, I will re-express this mess here, which is a single line, using my way. Okay, and you guys will go like, well, is that really necessary? This is how I write conditional statements. I specify all of the possible parts. Okay, There's the condition, there's the then statement, and there's the else statement. And I don't really care how many statements I have in each one. I always use open and close curly braces. In this case, I have a nested conditional statement, so I would do exactly the same thing. So now I go back and backfill. This is the condition. This is the condition. This is the action. W gets 1. This is the action. W gets 2. This is how I would express the same logic here. So this single line, which has multiple statements and is nested, is exactly the same thing as this one here, structurally. Okay? In other words, I do not spare the use of curly braces. What about the second one? Well, the second one, same thing. I have an outer conditional statement, a inner conditional statement, okay. The outer conditional statement has a condition of x is less than y. The inner conditional statement has a condition of x is less than z. And the single action for the then portion, which means only if x is less than y and x is less than z, w gets 1. Remember, this else is corresponding to this if here, which means w equals 2 is the else branch of the outer conditional statement, so it goes here. So if I were to recode this, I would have done it this way, even though it looks, well, it looks kind of longer than it needs to be. But you know what? I have specified every single spot that can possibly have something. If there's nothing to specify, I just leave it empty, open and close curly brace. But in the future, if I ever need to put any code over there, there is a place for it already. I don't have to deal with how to parse, something like this as a C compiler. Are we doing okay so far with the method that I use to write code? Yep.
Can you just do that for easier debugging?
You mean the second way, the way I do it?
Write it that way, yeah.
Absolutely. It's actually easier to write as well because most editors have auto indent, which means, okay, let me show you what auto indent means and why it is helpful. Okay, so let me go EX5. So auto indent means if I do something like this and I go back to here and I say if blah blah blah, oh, this is with auto indent turned off. Okay, do it again. I have auto indent turned on this time. So if I have, do you see? Okay, so now I don't have to go back to, well, okay, if I don't put the close curly brace right away, then later on I have to figure out, okay, which open curly brace am I closing now? What is supposed to be the indentation level? If I do it this way, I never have to worry about it. In other words, I put out the empty skeletal structure of the code first. Then I go back and put in the content that I actually need to put in. And over the years, okay, and that's many years, I have found this way of writing code to be easier to deal with in the long run. Even though most people will say, but you may not even have anything to specify in this particular else case. There may be nothing to do, when the condition is not met. But I'm going to put it there anyway, okay? Because there may be something later on that I want to put in there, but I have a place to put that code already without causing any potential confusion. Are there any questions about this particular topic? Because this is a very important topic. You guys are just starting to write code in C and C++, okay? So I think it is important to understand without using structured code like this, you will have to deal with something like this, and the only way to read this correctly is to read it like a compiler, which is not easy to do. Okay? To me, it is not as difficult because I have been writing compilers for a long time. So, how a compiler works, how it sees things, how it parses the tokens and whatnot is somewhat familiar to me. But to you guys, it's not going to be easy. So to avoid having to think like a compiler, which is not easy, you can just use extra curly braces to make everything clear. Are we taking on this topic okay here? Okay. Now, having said that, okay, in the exam questions, I will give you something like this, and then ask you, I'll give you specific values of x, y, and z, and then I'll ask you, what is the value of w after that? So you will still have to understand it. It's just that you won't be doing that a whole lot. It's only for answering certain questions. Yep.
Your exams are open note, open book, right?
It is. They're open book, open notes. Yes.
Does that mean that we're able to access the computer?
No. Well, okay. That part depends on whether I can get everybody a computer in the class or not. Okay. Because right now we still have people in the back. They do not have access to a computer. If everybody can have access to a computer, then it will be, you can use a computer. Okay. Now, on the other hand, if you have access to a computer, then I'll assume that you have access to a virtual machine, which also means, certain types of questions I cannot ask anymore.
Okay. You're just gonna have us do it?
Well, okay. In the past, okay, on a paper test, I would ask questions like, okay, this is the code. Tell me what is the end result of, okay, what are the values of variables at the end of this execution? But if you have access to the virtual machine, you can just type in the code, run it, and then tell me what it is, right? Which defeats the whole purpose.
Yeah.
So I would have no choice, okay, in that case, but to ask questions that are it has more to do with actually writing the code. So I will describe what needs to be done, and then you guys will have to write the code to do it.
I was just wondering, because if we could, because I don't really take handnotes in this class. I usually refer to all the notes.
You can print that out.
Oh, okay, yeah.
Yeah, you can.
Sense.
Yeah, you can print out all the notes that are electronic on a piece of paper.
But will we know all the information that's gonna come from the exam? Will we be able to have a basic syllabus study for?
It will be all based on the material that we have talked about.
Okay.
Yep. Go ahead.
So if students have the time, could they be able to look up material from your video lectures and use that for the exam, or no?
Okay, if you can use a computer, okay, during the test, I will be assuming that you can access the YouTube as well.
Okay.
Is it a good idea? Probably not. Okay, because the chances that you can locate content really quickly when I have hours and hours and hours of lecture is not very well. Okay, so the best way to prepare for an exam is not to rely on the YouTube material during the exam, but to review that material prior to the exam, and then write down on your own quote-unquote cheat sheet. It's not cheating because you are allowed to use any printed material, but have your own compiled material. Not compiled, it's in the compiler, but it's something that you put together and bring that to the test. But you will still have full access to the notes on Moodle. You still have full access to the YouTube stuff. If I can have one computer for each person, you have access to Google. You can select the question text, right click, and say Google search for this sentence. Okay, but the chances of getting the actual answer that way is almost none, because I always make new questions every year. Every semester, actually. So the test is not about memorization. It's not about whether you can look up something. It's about, can you apply what you're supposed to understand at that point. Okay, so having computer access may not be a good thing, because then I would be assuming you should not be making syntax errors anymore because you have access to a compiler. Whereas a paper test, I can go missing a semicolon here, but since you don't have a compiler to check for things like that, I'm going to let you pass. Okay, so there are definitely trade-offs between using the computer or not using the computer for exams. When we get to that point, we'll decide. I'll decide what to do. Yep.
I was also just one more question. Are you gonna have us write pseudocode?
Nope, no pseudocoding in this class. It's all C++ code. Pseudocode was done in the previous class.
I don't know if I'm using the right term, but just having us write it down on a piece of paper, basically the same syntax.
Those type of answers are very hard to grade. I'll tell you why. Okay, I'll tell you why. Okay, in an answer like this. Okay, so let's say this is the answer. Okay, if someone puts in something like this, they forget to close a parenthesis. How many points should I take off? Okay, well, it depends on whether it is important or not, right? If they write a code like this and missing a closed curly brace, how many points should I take off? Well, that's important because the closed curly brace matching this open curly brace here can be here, which means one thing, but it can also be here, which means something else. So that makes it very hard to do grading, because with any type of syntax error or type or writing error, it can be a very simple thing where I should not be deducting a lot of points, but it can also reflect a concept misunderstanding where I need to take off more points. So that's why I have to design the test so it's kind of clear cut whether someone understands the concept or not.
Okay.
All right. Any other questions? The homework is due on Wednesday. There are two things due on Wednesday. Okay. There's the more operator quote-unquote quiz due on Wednesday, and then there's the homework due on Wednesday as well. How do we know what is due on Wednesday or what other day? You go to the home page of the class, you go to upcoming events, which is on the right hand side, and you can see Find Mid is due on the 16th at 1 p.m. and more operators, which is in the form of a quiz, is also closed at the same time. Okay, so this is how you can keep track of, okay, but what am I supposed to do at this point? What is due, in this week? This is how you can do it. All right, well, that's the end of today's lecture. So I'll leave you guys to do your homework.